continuation of the last videos on aromatic electrophilic substitution of BSc Part 1 Organic Chemistry. In this video, we are going to study about orientation based on charge distribution. Let's take them one by one. First is inductive effect. The group already present on benzene ring changes the electron density of neighboring carbon atom. It depends on the electronegativity difference of carbon atom and adjacent atom of the substituent, that is with which it is directly bonded. It is of two types. Minus R effect. If the substituents are electron attracting, this is minus R effect, which results in the decrease in electron density of the neighboring carbon atom due to the substituent. Plus R effect. If the substituents are electron releasing, it shows plus I effect, and this results in the increase in electron density of neighboring carbon atom due to the substituent. Then the next effect is resonance effect or mesomeric effect. If lone pair of electrons present on the substituent groups are in conjugation with pi electrons of benzene ring, then this results in plus R or plus M effect. If we take the example of plus R or plus M effect, then we see, for example, if we are taking phenol, the electron pair on the oxygen of the phenol enters into conjugation and a double bond is formed between oxygen and the carbon of the benzene ring. And the double bond between the carbon 1 and carbon 2 shifts on the second carbon, which becomes negatively charged. And now, by the successive migration of the double bond within the ring, the negative charge shifts from the second position to the fourth position to the sixth position, and then later the double bond between the electrons of the double bond between oxygen of the substituent group and the carbon of the benzene ring shifts on the oxygen, and the lone pair of the electrons on the sixth carbon atom shifts between C1 and C6, forming a bond between C1 and C6, and neutrality is retained. So we see that resonating structures increase the stability, and in this we see the negative charge develops on ortho and para positions. Hence the incoming electrophile will attack these positions in preference to the meta position, which has less electron density than the ortho and para positions. Now, if the pi electrons present in the group due to the double bond or the triple bond are present in the group are in conjugation with the pi electrons of the benzene ring, then this results in minus R or minus M effect. So, if we consider this compound in which in the substituent there is a double bond between carbon and oxygen. So, here the double bond between the carbon and oxygen of the substituent shifts on the oxygen, making it negative, and the double bond between the C1 and C2 of the benzene ring moves out of the benzene ring, forming a double bond between carbon of the substituent and the carbon atom of the benzene, and positive charge is developed on the second carbon atom. By successive shifting of the double bond within the ring, this positive charge shifts from the second position to the fourth position to the sixth position, and then the double bond between carbon of the substituent and this carbon of the benzene shifts between C1 and C6 of the benzene, forming a double bond, and the electron pair which is on the negative oxygen moves between C and O of the substituent, forming a double bond between the C and O of the substituent, and then neutrality is retained. And we see that in this positive charge develops on the ortho and para positions. Thus, in this the meta positions will be more electron rich than the ortho and para positions. Hence, the incoming electrophile will attack preferably on the meta positions than the ortho and para positions. Thus, we see that plus R plus M effect increases the electron density of the benzene ring, and minus R and minus M effect decreases the electron density on the benzene ring. Now we come to the hyperconjugation effect. Plus I effect of alkyl group is in the following sequence. We see that the methyl group is the least plus I effect, and the third butyl has the highest plus I effect. But Baker and Nathan showed from the reaction determination method that the electron releasing effect of the alkyl group is in the following sequence, which is a reverse of the inductive effect. That is, the methyl group has the highest electron releasing effect, and the third butyl shows the minimum electron releasing effect. To explain the reverse behavior, Baker and Nathan suggested that if carbon of the HC is bonded with unsaturated carbon atom, then delocalization of sigma electron of CH bond takes place by unsaturated system. So if we take this unsaturated system, then we see the double bond pair between the C and C shifts on one carbon atom which attains negative charge, and the single bond between hydrogen and carbon shifts making this positive double bonded, and the hydrogen becomes positively charged. And this conjugation takes place between single and double bond and is known as hyperconjugation. And due to this hyperconjugation, partial ionic character is developed between H and C bond, and this hyperconjugation is also known as no bond resonance, because we see that for a moment there is no existence of bond between hydrogen and carbon for a moment, and after a particular moment this bond formation will take place, but for a moment there is no bond between hydrogen and carbon, and this hydrogen is in the protonic state. So we see the alkyl substituents show plus I effect, and hyperconjugative effect of the alkyl group increases the electron density on the benzene ring. So alkyl group is ortho and para directing. So we see this methyl group. In this we have marks hydrogen as 1, 2, 3. The bond between carbon and hydrogen H1 shifts, and there forms a double bond between carbon of the benzene ring, and the double bond between C1 and C2 shifts on the second carbon atom, making it negatively charged. By the successive shifting of the migration of the double bond within the ring, the negative charge also shifts from the second position to the fourth position to the sixth position, and in this we see the double bond between the carbon of the methyl group and the carbon of the benzene moves between the carbon of the substituent and the H1 of the substituent, and the bond is formed and the neutrality is obtained, because the negative electron pair, that is negative charge due to the electron pair, this electron pair shifts between C1 and C6, and the double bond is formed between C1 and C6. So in all, the neutrality is obtained, and this is known as hyperconjugative effect. And we see that in these three resonating structures, there is no bond between carbon of the methyl group and this first hydrogen atom. Hence this is known as no bond resonance. Now we come to orientation based on stability of adenine ion, ortho and para directors. If substituent S has at least one lone pair of electrons, then lone pair determines the orientation. For example, phenol, aniline, acetanilide, chlorobenzene, they all have lone pair of electrons on the atom which is directly bonded with the benzene. Hence these show ortho and para directing effect. So such compounds exhibit plus R effect. If we compare now the ortho, para and meta attacks on such compounds, then it is seen that from ortho and para attack, 4 resonating structures are formed of adenine in which they are highly stable, while with meta attack 3 resonating structures are formed which are not very stable. So in this condition, if electrophile attacks a benzene derivative having electro-releasing substituent, then it will preferably attack ortho and para position. So if we compare ortho, para and meta attack, then we see then in ortho attack the electrophile attaches itself to the ortho position to the substituent, and this third carbon attains positive charge. Now by the shifting of the double bond within the ring, this plus positive charge shifts from the third position to the fifth position to the first position, and in the next stage those 3 isomers are formed, and in the fourth isomer the electron pair of the substituent forms a double bond with the C1 of the benzene, and thus we get 4 resonating structures. In the para attack, if we see the double bond here forms a bond with the electrophile, covalent bond with the electrophile, and a positive charge is developed on the 5th carbon atom, and by the migration of the double bond within the ring, the positive charge shifts from the 5th carbon to the 1st carbon to the 3rd carbon, and so these 3 isomers are formed, and we see that the lone pair of the electron shifts between the substituent and the carbon of the benzene ring and forms a double bond between the substituent and the carbon atom of the benzene ring. Thus 4th isomer is formed. Now if we see the meta attack, then we see that in the meta attack